What the bleep is Bitcoin? This is kind of a funny question, but I think it's a really great question to ask anyone who you meet who claims to know anything about Bitcoin, because you'll get a lot of different answers. The first kind of answer that you might get is that Bitcoin is magic internet money. And this is actually not a horrible answer, because Bitcoin is pretty magical. It can do a lot of things that we were never able to do before, but it doesn't really capture the whole picture, because we actually do know how Bitcoin works. It's not magic. The next type of answer you might get is that Bitcoin is drugs. And this is not wholly inaccurate. There are a lot of drugs that you can buy online using Bitcoin, but you can also buy a lot of drugs using USD, so maybe this isn't really a perfect thing to say Bitcoin is drugs either. Another answer that you might get is that Bitcoin is gambling, either through playing games or through currency speculation. And again, this is a lot of what is happening with Bitcoin right now, but it doesn't really capture the whole picture either. There's a lot else that happens with Bitcoin. You might also get some more savory answers, like Bitcoin is banking the unbanked. And this is a really good thing that Bitcoin can do. It's a gatewayless interface to a lot of banking infrastructure that has never existed before. So anybody who has a phone pretty much can get access. And there are billions of people who have access to phones but don't have access to banking infrastructure. So it can really do a lot for these types of issues. Another answer that you might get, and it's just the notion that Bitcoin is normal money. You can do all the things that you can do with normal money with Bitcoin, and therefore Bitcoin is normal money. But it also fails to capture the entire picture, because there's a lot that you can do with Bitcoin that you can't do with normal money. These all kind of point at a general question, which is, what is Bitcoin for society? So what is the thing that Bitcoin should be doing for us, and where should we put this and treat it in our society? And I don't want to answer this question, because it's kind of contentious. We've seen that Bitcoin can do a lot of different things so far, and to pin it in its early days down to one of them would be premature. So instead, there's another question we can ask, which will maybe help us answer this question later, which is, what is Bitcoin technically? So what underpins it, and how does it really work? And the way that I think is best to go about doing this is, I think we have to just answer, how can we design Bitcoin from scratch? So how can we go from the fundamental computer science techniques and build up something like Bitcoin? And the place to start, I think, is with serial numbers. So a serial number is just a unique identifier for some item. So we're familiar with this from the idea of each dollar bill we have has some serial number on it that lets us know this is a unique dollar bill. And if we give that to somebody else, they can say, like, well, does this have a serial number that matches any other dollar bill? No, this is actually a valid dollar bill. And so we have a general system where some user, Alice, can pass the serial number 10 to Bob, and then Bob can pass it on to Carol, and they can all say, great, I have this serial number that I can spend. And actually, if you kind of squint your eyes a little bit, fundamentally, this is a cryptocurrency. So this is just a way of passing numbers from person to person. Granted, this is actually probably the worst one you can imagine, because there are a lot of problems with it. And the first problem that we're going to look at is, well, what if Alice doesn't want to spend all of her serial number? What if Alice wants to make change? So in order to make change, we can say that Alice has 100 of a certain serial number, and then can send Bob 50 of that serial number, and then we'll have 50 remaining. And so the way this works in Bitcoin is it's kind of a universal cash register, where Alice puts in her bill and then takes out the appropriate bills later. And this doesn't just have to be 50-50. You can do any split you want. So you could do 79 and then whatever the change is for that. But there's still kind of a problem here, which is that what if some evil user, Eve, pretends to be Alice and then sends Bob the message saying, hey, here's 100 of serial number 10 that Alice owned, I'm Alice. She's going to be able to do this, and this is no good. This is identity theft, it's fraud, and Alice no longer has any money. So in order to prevent this, we can add in the notion of a signature. And so by adding a signature, what we're saying is that Alice has an unforgeable way of marking that she did indeed intend to send Bob some amount of Bitcoin. And this is kind of like a fingerprint. So it's something that only Alice has and nobody else will have, and nobody else can create. And in Bitcoin, these are done with public key cryptography, which is basically a very long random number that only you know, so nobody else can pretend to be you, because they won't be able to guess what your number is. But there's still kind of an underlying problem here, which is that, well, let's say that Eve sends Alice and Bob all of her serial number 10s. And now there's two people who aren't talking to one another who both think that they have all of a serial number. And then later on, they're going to find out that only one of them actually validly had this bill. And so this is kind of counterfeiting, or in Bitcoin, we call this a double spend. And we really want to disallow this. And so in order to solve this, we need to introduce this idea of a public ledger. So this is a single data set that everybody is looking at that records all of the transactional history. And by doing this, everybody will say, okay, this is authoritative. This has all the information. I can see you didn't send this to anyone else. I'm the only person with this one. You can verify balances, and this is all really good. But there's still kind of some problems with having this universal log, which is, well, who's going to maintain this? Do we let God maintain the log? Because there's really no one that we'd want to trust with this sacred right of making sure all of transactional history is true. And as a side note, this is kind of where we are right now with banking systems, is there's just kind of a log, and we don't really know who's in charge of maintaining it, but we're okay with this. And if the banks decide, maybe they want to make some more money, then they can do this because we need to then later audit them, and it's a whole big process. But it would be a lot better if we had a universal log that everybody was taking care of. So the solution to this is if everybody is using the same log and everybody is maintaining it and keeping their own copy, then everybody will be able to point out when something goes wrong. But there's still kind of an issue, which is, well, what about the little guy? So if one person decides to convince everyone else that another person no longer has any funds, and then everybody else in the world switches to a new log, then this person has no ground to stand on because everybody else is going to say, well, hey, it's not in the log. So what we really need to address this is we need a log which cannot be changed, which is authoritative, and nobody can go back and change history, alter the course, and say, well, this person no longer has money. We need something that just cannot be changed ever. And in order to address this, we need to build something much more complicated. And this is what's really at the heart of Bitcoin and what makes it so special. And in order to get there, there are a number of concepts we need to introduce and that you need to understand before we can really understand how Bitcoin is doing this. And the first thing that we have is a hash. So this is not the hash that you'd buy with Bitcoin on Silk Road, nor is it the hash that you'd use on Twitter to express maybe some emotion. This is really just a small magic number to uniquely identify some piece of data. So it's kind of like a serial number for a piece of data. So you can imagine that the hash of 1 is just this very long number that was too big to fully fit on the slide. And even though they're small in comparison to maybe the data they can encode, let's say, all of Shakespeare's works in a single hash. It turns out that this number is much smaller, but it's still enough to represent, say, uniquely every atom in the universe. And so when you're talking about something that big, you really kind of wave your hands and say, okay, we're never going to create a conflict in this. Two things will never have the same serial number. And so the next concept that we need to introduce is called a Merkle tree. And so the idea behind a Merkle tree is that you take two pieces of data, take their hashes, and then combine those serial numbers together into a new piece of data, and then take that hash. So it's a way of compressing down to a single hash for multiple blocks of data. And then that top level hash, which represents many blocks of data, is called a Merkle root. And so when we're building this Merkle root, we can enforce some invariant of maybe all the data that goes into this has to have some special property. The next thing we need is called a hash chain. And so the idea of a hash chain is that you take blocks of data and you stitch them together by taking your first block, taking its hash, and then appending that hash onto your next block of data, and then taking that hash. And so what this does is this gives you at the end a final hash. So here we have HB3. And when you have that, if somebody wants to change any of the data in the first block, they cannot do this without changing all of the following hashes, and they won't be able to change any of the information. The next idea that's really important to bring in is hash cache. So this is where we make our hashes not only a serial number, but we also make them a hard puzzle to find this by letting the puzzle solver take in a random number of their choice and then looking for a hash that has some other special property. Maybe it has the word hello in it. And these puzzles can be made more difficult. And the only way to solve them, because of the way that hashes work, is just by trying all possibilities. So this is a little bit like you or I trying to solve a Sudoku Rubik's Cube. We're just going to be scrambling it for hours until we can finally figure out the damn thing. But maybe some smart person can solve these more intelligently, but chances are, and we are very confident with Bitcoin, that you actually can't solve these puzzles even if you have any knowledge. So this leads us to a Jeopardy question, which is, what is blockchain? So the blockchain is just a hash chain where the hashes are solutions to hash cache puzzles, and the data is a Merkle root of all transactions. So that's a little bit of a mouthful, but this gives us some really nice properties. Mostly that this is a non-precomputable thing. So it's based on all the transactions. So you have to have the current transactions to be able to solve the puzzle. And it has to have all the prior solutions. So you can't change anything of the previous data, nor can you start working on the puzzle for next week in advance. Everybody's working on the same puzzle at the same time. And all the old data is now protected. It's immutable because you're going to change the hashes otherwise. You'll know that the serial numbers don't match up. And so just to kind of review everything that we've built so far, we have this notion of a transaction, which is a message from Alice to Bob, which says, here's some amount of a serial number, and has Alice's fingerprint, which Bob can then check that that fingerprint is valid. We have the transaction Merkle root, which is the single hash which represents a ton of transactions. And when we put these transactions into this Merkle tree, we check the invariance that nobody has spent more money than they had or spent somebody else's money, and that all the signatures are indeed valid. We have this block header, which contains the hash cache, which is where we take this Merkle root, and we take a number of our choice, and we take the last solution, and then we try and find a hash by changing this number, and try and find what the special property of it's smaller than a certain bound. And so we can take all of these things together and stitch them finally into the hash chain. And now we have the system where we've hashed together these block headers, and we have all of their hashes feeding into the next one. And so by the time we get to PB3, nobody can change any of the transactions ever that existed in the Merkle root 1. If you wanted to do this, you would have to go back to that point in time and then resolve all the puzzles. And then by the time you catch up, there'll have been new puzzles solved. So nobody can really change history. We have an authoritative record of what has happened. And this is a really powerful idea. So there's still kind of a problem here, which is where did Alice get her Bitcoin from? And it's very beautifully wrapped into Bitcoin in that you actually get this by solving the puzzles. So Alice identifies herself as a solver in her solution, and then the rest of the network says, okay, well now you have some new Bitcoin to send around. And that's really just how it works. And the way she does this is she adds in just another garbage transaction that really is not valid, but the rest of the network is willing to recognize as valid because it's the process of solving these puzzles. And this puzzle, in the solution, is kind of called a coin-based transaction. So there's still a problem, which is that you want to use Bitcoin, not solve puzzles. And the nice thing about this solution is that, well, you actually don't have to care about sending in order to solve it. You can just be solving the puzzles without caring about sending at all. And so this is a process known as mining. So mining separates the puzzle away from sending. And the important thing that the miners are doing, so a lot of people say miners are just wasting electricity. Miners are actually solving all these puzzles and making sure that all transactions are valid. So they are the ones with the sacred right of keeping the log. But there's still kind of a problem, which is, well, okay, well, maybe there are miners, but where did the numbers come from? There had to be a first block. Somebody had to be mining some transactions, and where did those transactions come from originally? Depending on your outlook on life, this will either be really satisfactory or completely unsatisfactory. It's a Genesis story. So Satoshi said, let there be Bitcoin, and there was Bitcoin. You know, he really said that the chancellor is on the brink of a second bailout for banks, but that's as an aside. Essentially, Satoshi just got this started and said, okay, let's start Bitcoin. Just recognize that this thing has no reason to exist except for the fact that we're going to make it happen, and it happened. So there's still a number of problems with my explanations here, and you can nitpick them to a very successful degree. But I think that overall, we're kind of at the point where we have like a very broad understanding of what Bitcoin is and how it's actually working at a deep level. We've got this 10,000-foot view with eagle-eye vision on the really important parts. And this is going to let us look at some of the more interesting things that are happening currently in Bitcoin. The first of which I want to tell you about is multi-signature transactions. So what this is a bill which can only be spent when it has 2 different fingerprints on it. And those fingerprints have to come from a set of, let's say, 3 people. And so what this lets you do is this lets you build organizational structure into a transaction. And what you can say is perhaps you can do an escrow transaction where one person is going to be your escrower, or you can have a multi-factor bank account, essentially, where you have your keys stored in multiple places and you have to go to 2 different safety deposit boxes to get your funds out. And so this lets you build really, really powerful structures. The other really cool thing that I want to tell you about is colored coins. So the idea of a colored coin is that instead of sending Bitcoin, which represents the value in the amount that you send, you just send a nominal amount with a color. So this color is just a label of your choice. And when you send this color to someone else, they can then send that colored Bitcoin on to another person. And they're going to be able to verify that you are the original colorer of that Bitcoin. And this lets you build, for example, an IPO in Bitcoin. So if Alice wants to issue stock for her company, she can now just color a coin which says, this is my IPO coin, and then this can be traded around as a distributed stock exchange with no gateways. Anybody can now IPO anything they want instantly. And this is an amazingly powerful idea, and there's a lot that we're going to see happening with colored coins. The final idea that I want to tell you about is zero cash. So zero cash actually uproots a lot of what we previously built and says, let's replace this public ledger that keeps a record of all transactions publicly, and let's do a zero-knowledge proof that a valid transaction happened. And what a zero-knowledge proof is it's saying, let's prove something without showing how we proved it. And this, in Bitcoin, what this lets you do is it lets you essentially just say valid transaction, but you're not going to know who sent it, you're not going to know who they sent it to, and you're not going to know how much they sent. So it's completely anonymous, like cash is today. In Bitcoin, you may have heard otherwise, but Bitcoin is not anonymous at all. So what is a zero-knowledge proof? Just real quick, I'm going to explain how this works. So let's say Alice presents Bob with some maze with a number of locked doors. And Alice doesn't want to know which key Bob has, but just wants to know that Bob is able to get through the maze. So Bob can either unlock the top door, he can unlock the middle door, and either way, he's going to be able to get to Alice. But if he doesn't have a valid key, Alice is going to know that Bob wasn't able to finish the maze. So this is a kind of proto-zero-knowledge proof. It kind of shows you what the general idea is of it. And so we've seen a lot about Bitcoin, and I think we have actually a pretty good understanding of what it's doing. And even though I was using dollar bills to represent the currency that we're sending around, it really isn't a currency. We're just sending around numbers. If you can do the IPO coin, that's not a currency, that's a stock. And really, we've seen Bitcoin as just a way of passing around numbers. That's our original definition on the first slide, is this is just a way to send numbers around. It's not really money, it's just numbers. And it can do money. You can do currency on it, just like we say the internet isn't books, but the internet can do books. And we're kind of at this point where a lot of people are saying that, well, Bitcoin is just money, and it's a lot more similar to the internet in this respect of the internet isn't really books. And at this point, I guess I would pose back to you, now that you have so much knowledge on Bitcoin and cryptocurrency, well, what the bleep is Bitcoin? Thank you.